And Ohm's law states that the voltage, that's what it says, the voltage across conducting material is directly proportional to the current flowing through the conducting material. Through the material. That's really Ohm's law. In a smaller, an easier way of writing that, anyone knows Ohm's law? V equals what? I times R. Bless you. That's Ohm's law. The voltage is directly proportional, or the current is directly proportional to the voltage. You can look at it either way. Meaning what? If I take a voltage source here, I have a resistor, there's my resistor from last class, that's a picture of a resistor. And I put a voltage across the resistor of 10 volts, and it's a 100 ohm resistor. There will be a current going through that, and the current goes through a resistor from plus to minus, just like the water goes from high ground to low ground. So the voltage using Ohm's law, V equals I times R. V is 10, I is unknown, I'm looking for it, and the resistor is 100. So I equals what? 0.1 amp. It says the voltage across conducting material is directly proportional. What does that mean, directly proportional, in math?
One goes up, so does the other one?
Yes, if one goes up, the other one goes up. If one decreases, the other one decreases. So if I increase the voltage here and keep the resistor the same, let's make the voltage double that and see what will happen to the current. Does the current becomes double that too? $20 equals I times R, which is what in this case, 100. I equals what? 0.2 amp. So the voltage doubled, guess what happened to the current? Doubles too. If one increases, the other one increases. If one decreases, the other one decreases. That's Ohm's law. If you graph Ohm's law, you do voltage versus current, guess what your slope is going to be? Think about the math.
Positive.
I know positive, what's the value of it?
1.
Nope. If you do the voltage here, and this is current here, the slope of that line, if you look at the slope, if you take 2 points on that and you find the slope, the rise over the run. What is the rise? Isn't that the change in the voltage? And what's the run? The change in I. So the slope is the change in voltage over the current. Change in current. Voltage over current. Well, take Ohm's law here. Let's look at that. Ohm's law says what? V equals I over R. Let's say I want to solve this for R. How do you solve it for R?
Divide by I.
Divide both sides by I. So R equals what? V over I. Well, what do you know? Voltage over current. That's the slope. What's voltage over current? That's your resistor. So if you calculate the slope for them, you'll find out it's the resistor. Yeah. And if you were to solve for R, we did R. If you were to solve for I, what is I will be, by the way, from that equation? V equals I times R. If you're looking for I equals what? V over R. Why is that important? Well, let's go to last class. We talked about power. Power could be positive or negative. We said our power, it's either positive or negative, V times I. If it's positive, the positive indicate the power was what? Absorbed. It was taken. If the power is negative, the negative indicator was what? Supplied. We said last time, just refresh your memory, if you have a positive current, let's say a plus 2 amp, entering 5 volts. If a positive current entering the positive terminal, what happens to that power? Is absorbed or supplied? That's taken, absorbed. So the power in this case will be positive. That's the positive sign convention. We talked about that last time, 2 videos ago. 2 times 5, which is positive 10 watts. On the other hand, if I have 2 amps, and this happens to be negative, positive 5 volts, somebody measure that, we find out this end is negative, that end is positive 5 volts, then the power in this case will be supplied. It's silly for a resistor to supply power, I'm just trying to make a point. So maybe instead of using a resistor, I'll just use an element here. I'm not telling you what's in the box here. How is that? Usually a resistor will absorb the power, most of the time. So now you get the current entering what? The negative that's being supplied, and the value of that power, 2 times 5, which is negative 10 watts. Well, let's bring in Ohm's law. Power, again, we're going to modify that equation, is V times I. But Ohm's law says V equals what? I times R. So if I take the V out of this now and replace it with I times R, what are you going to have? I times R times I. So power can be calculated also by using what? I squared times R. So if you know the current and the resistor, you don't have to find the voltage first and calculate the power. You can use that equation. Or if you look at Ohm's law, what is I equal to? V over R. So V times V over R, we can say power is what? V squared over R. So 3 ways to calculate the power. And again, still could be positive or negative. It depends if it is supplying or absorbing here. Could be V times I if you know both of them. If you know the current and the resistor only, you can use that. Or if you know the voltage and the resistor, you can use this. You can use any one of them. I'm just going to take some examples now and just have fun with them. Okay. Now, a couple of things to remember before I get to that. Let me talk about parallel because it comes in handy. This has its own section coming up later. When something's connected in parallel, what does that mean? In parallel. Let's have this element. I'm not even telling you what the element is. And I have another element. How do you connect these in parallel? In parallel, that means you take the top of this, attach it to the top of this. And you take the bottom of this, attach it to the bottom of that. That's connected in parallel. If they are connected in parallel, the voltage is the same. The current usually not. The only time the current will be the same if these guys are equal. But the current usually not the same unless they are equal. So for example, let's take, I have two resistors here, and one is 10 ohm, and one is 100 ohm. And I attach a voltage source in parallel with them. All three are in parallel now. And let's make the value of this 10 volts. Notice they're all attached in parallel. The top attached to the top. The bottom is attached to the bottom. All three are attached together. So that tells me the voltage across each one of them is going to be the same. The voltage is the same. So what is the voltage right here then? 10. And what's the voltage right here? 10. They're in parallel. They must have the same voltage. Now, is the current the same? Let me find this current through that. We'll call it I sub 1. And let me find the current through this. We'll call it I sub 2. Now notice I drew the current pointing down. Why? Because the current through the resistor will travel from the high to the low. This is the high potential, that's the low potential. That's the high voltage, that's the low voltage. The current will go from high to low, travel down. So what do we know about this? Can we find what I sub 1 is? Well, we can use Ohm's law. V equals I times R. Let's look at this one. What is the voltage here for that resistor? 10. The current is I sub 1. And what's the resistor there? 10. So what's I sub 1 equal to? 1 amp. Now let's look at this one. V equals I times R. V is 10. I is I sub 2 here. And R is what? 100. What's I sub 2 equal to? 10 divided by 100. 0.1 amp. Remember, in math we'll say the current will take the least resistive path. The smaller the resistor, the more current going through it. Notice this resistor is 10 times less than that. So what's the current through this? 10 times more than that. Least resistive. The smaller the resistor, the more current going through it. The larger the resistor, the less current. Resistor, the name resistor, resist, block. It wants to block the current from going through, resistor from going through it. So the bigger the resistors, you're trying to hold the door closed. There's somebody pushing on the door from the outside. I'm pushing, trying to block it. Now if you join me, if 10 other people join me, we're going to give it a more force, more blockage force. So he's not going to be able to go through that door. So that's what happens here. This resistor is 10 times bigger than this. There's a lot of blockage there, so there's less current going through it. Now, as I said, the current is different. That's not always the case. A current could be the same. The current will be the same if the two resistors were equal. So if I take that and I redo the same circuit, and I make the resistors equal, I don't care what value we use, like 10 and 10, since they are equal, the current is going to be the same. So that's why I don't want to say the current is different. The current most of the time is different, but it could be the same if the resistors are equal. Notice this is in parallel, all three of them, so they have the same voltage. There's 10 volt, I1, I2. And if I use Ohm's law for this one, V equals I times R. 10 equals I sub 1 times 10. I sub 1 is 1 amp. V equals IR. I sub 2 here, I'm doing the right side, times 10. That's a 10 here. V is 10. What's I sub 2 equal to? 1 amp. So notice they are in this case equal to. The current is the same. So when they're in parallel, the current could be the same, but the only time the current will be the same when the resistors are the same. But we should know that when they're connected in parallel, the voltage is always the same. This is always true. Now, one more thing about this circuit, if we look at it, let's look at the power. We have a positive current entering the positive source. So the power by the 10 ohm resistor, in this case, will be positive. It's being taken. Positive current, because the current is 1 amp coming down, entering the plus. It's I squared times R. I can use that. I know I sub 1, which is what? 1 square it times a 10, which is what? 10 watts. What is the power absorbed by that resistor? Again, I said absorb because you get positive current. It's a 0.1 positive entering the plus. So it's plus I2 squared times R. I2 is 0.1, square it, times 100, and that's what? 1 watts, that's positive. So both of these resistors actually absorb some power. Well, let's look at the source, that 10 volts. Now keep in mind, there's current coming up, moving in this direction. That current gets to this junction, splits. Some of it comes down this way, some of it goes down that direction. So what's the value of that current? Anyone?
I1 plus I2.
Yes, I sub 1 plus I sub 2. Has to split, and that's what, 1.1 amp? So you got 1.1 amp going this direction. That means what's coming from down here?
1.1.
Yep, going up there. It has to be. There's no other branch. There's no other place to come from. So you have a positive current entering the negative here. What do you think about the power by this source? Is it absorbed or supplied? Supplied. So the power by the source, it's negative V times I. Negative V, which is what? 10. I, which is what? 1.1, which is negative 11 watts. Interesting. What is the total power absorbed by the two resistors when you add them? 11 watts, and what's the power supplied by the source? 11. Conservation of power, conservation of energy. The power supplied always going to equal the power absorbed. Now, the one thing to remember about parallel, you could never really connect resistors and not resistors, voltage sources in parallel. When your car battery dies, and it's supposed to be 12 volts here, your car, but now it's dead. It's at 8 volts. You call your friend, they bring in their car, and their car is running well, has a 12 volt right here. And what do? To jumpstart your car, you take the plus from your car to the plus from their car. And you take the negative from your car, some people attach it to the negative here. And when you do that, what happens? You'll see sparks. Why? Well, they are connected how?
In parallel.
In parallel, the voltage has to be the same. How can 8 volt equals 12 volts? Can't. So what will happen quickly, this one will try to charge this one to 12 volts. And your car will jump start. But you never want to connect voltage sources in parallel. Especially if it's not if you have a dependent or independent source. You take an independent source, this guy says, day or night, I'm going to give you 5 volts. Anytime you use me, that's going to be 5 volts out of me, and that's it. I don't care what you attach to me. Well, you go and attach to it 10 volts, now we got a problem. One of them is going to be fried. Because now you're forcing this one to give you 10 volts, he can only give you 5 volts. Can't. You just killed one of the sources. So you never want to attach voltage sources in parallel, unless they have the same value. If they have the same value, that's different. If you take a 10 and 10, you still got a 10. So this is not good. Now the other one I'll talk about, what about if you attach them in series? Instead of parallel. When you attach something in series, let's say something like this. You take this source and you attach a resistor to it like this. You can attach another one if you want to, another resistor there. And you can attach another one if you want to. All of these are attached in series. Notice the end of one, like if I'm trying to attach these in series, I might have something like that. Perfect. Let's say these are two resistors. You don't want to attach them in series. Notice they're different. One is blue, one is red. You attach the end of this to the tail of that one. Now they attach in series. When you attach them in parallel, the top of this attached to the top of this, the bottom of this attached to the bottom. That's parallel. Now you're only attaching one end, like this. Well, if there's, again, imagine these are water hoses. If there's water going through this, what will happen? That water has to go through that. So that means what? The current has to be the same. When you attach them in series, the current has to be the same. So for the other one I wrote what? Voltage is the same. For this I'll say current is the same. The current will be the same. It's the same current going through them. Now I'll give you another tip. If you only have one source like this, the current through the source always going to go in that direction. Why? Why did I draw the current go in that direction if the value is positive here? Because that current has to do what? supply power. And how do you supply the power? You want a positive current to enter what? The negative terminal of that source. So in this case, the current will be going that direction. So if I take a simple circuit like this, I just use one resistor for now. And I said, can you tell me what the current through that should be? And which direction is it going to be going? Or I might define I sub 1. I said, can you find I sub 1? I define I sub 1 as the current going this way. Well, I look at these two and I go, how are these two connected? Right now, these two are connected in parallel, aren't they? Right? So if they're connected in parallel, wait a minute, the voltage is the same. If the voltage is the same, that means the voltage here is going to be plus to minus 10 volts. You see, you just finished telling us if you connect the top of this to the end of that, that's connected in series. What's true. But what happened here, that's not what you have. You have the top to the top, the bottom to the bottom. You have it attached like this. That's what you haven't attached. This is your source, this is your resistor. You're attaching the top to the top, the bottom to the bottom. They are in parallel. If I attach them like this, if I disconnect this, put something else, they're no longer in parallel. So I'll give you that example in a minute there. So this is 10 volts. Ohm's law says V equals I times R. V is 10. I times 5. I equals 2 amps. And my direction is correct. It's going to go down through this, it's going to come up through that. This has to absorb the power. This has to supply. So the current through this will be coming down. That's what the arrow means. Coming down, going up. Coming down through this to take the V times I, 20 watts here, and going up there to supply 20 watts. What's not in parallel is this. Now, these two are not in parallel. They're actually connected in series. These two are connected in series. These two are connected. Only one end attached. So these guys are connected in series. So this is parallel here. This is series here. Well, if they're connected in series, they must have what? The same current. They must have the same current. If I know what that current, I'm done. Think about this. The current is the same. The current through the source has to be going this way. The current through that has to be going that way. And the current through this has to be coming this way. It's one direction, traveling like this. Same current. This is going to be absorbing power. This is going to be supplying power.
Is it the lowest current?
What do you mean the lowest? There's only one current because that's a DC source.
Okay.
Total resistance of the circuit?
Well, we didn't cover that, you're right, but we didn't cover that yet. But I can use the power here to solve it. Conservation of power. The power supply has to equal what? The power absorbed. So if I know what that is, I might be, probably not, because I didn't give you enough information. But you're right, I can find the total resistance that's here. There's also something called voltage division and something called current division. I can't do the power because you'll have, the I will disappear from all sides of it. So you're right, I have to combine these guys together to get one resistor, but we didn't discuss it yet. You know, we'll do that next video or next class. We'll discuss when you have resistors connected like this, what happens? Can you combine them into a single resistor? And what's the value of that resistor? When you have, like these guys here, yes, I can combine them into one resistor. When you have resistors connected in parallel, or a combination of that, I can combine them into one single resistor. We'll talk about parallel, series, configuration, how to combine them. We'll also talk about current division, voltage division next time. You know, with the information I gave you here, we really can't finish this unless I give you something else. If I said to you, guess what? Somebody came in when I was gone, measure the voltage here. And that voltage here was 6 or 7. You know? This is 2/3, this has to be 66.7. The voltage here is 66.7 volts. Then I can figure out what the current using Ohm's law. You know? Okay, I'll stop with this one here, and we'll finish it next time. We'll talk about simplifying this so we can solve it. But right now, I'm stuck because I didn't give you enough information.